Welcome back to the Turnaround Team Podcast. I'm your host, Craig Pinkard. Today's show is sponsored by Turnaround Specialty Group. They are the leading service provider of API, refractory inspections, and testing. They can be found on Facebook, LinkedIn, Instagram, and of course, turnaroundspecialtygroup.com. Our guest today is Wouter Garot. He is the CEO of Silicon Refractory Anchoring System. So thank you very much for joining us today.
Thanks for having me.
So let's just start right from the beginning. Maybe you can give us a rundown on the origins of Silicon.
Yes, I can. We were approached by somebody from the Carborundum Group back in 1981. And Carborundum at that time was a manufacturer of ceramic fiber, as you may know. And they were needing ceramic fiber pins and modules, anchoring systems for their ceramic fibers. And they asked me if I wanted to manufacture that, because one of the salesmen was actually a very good friend of mine. And he knew I was working in the heat-resisting alloy market. I was working for Rolled Alloys at the time. Rolled Alloys, obviously, a very well-known American supplier of raw materials. So I was working for them, and I thought, well, I'm sure you can get them somewhere else, But he said, no, we're having difficulty. There's people don't understand our needs and things like that. So I thought about it for 3 months. And then I said, yeah, I'm going to go for it. So in January 1982, I started my company, and I made the first samples, which was obviously very difficult because I had no production experience at all, and I had to learn everything from scratch. So learning how to make tooling, how to run machines, et cetera, et cetera. And it took me about 1 year to really get going into production. But my customer helped me a lot, and that's how I got going. And from one thing came another. After one customer, the next customer, and they all kind of fell into my lap, as it were, because they all needed support in their refractory anchoring needs. Also the people that were using monolithics. So that's how it started, basically. And we continued manufacturing the anchors until 1989, when I was asked by a customer who had a problem in his FCC with the hex metal. Hex metal was not lasting very long, and it was coming off, and it was a terrible thing to repair. And the downtime was so expensive every time. So he asked me if I could come up with a solution to have an alternative for hex metal. And so we started off at that time with a product called the Speed Cell, which was the forerunner of the Speed Hex. And we started manufacturing that, and that worked quite well until, let's say, the 2006, when they had a big catastrophe at one of the refineries. And they said, okay, well, we're not going to use speed cells anymore. We want something else. So we re-engineered that product, and we came up with the Speed X3, which is like the latest development that we have now. And at that time as well, we also were thinking about stud welding at the time, and we were renting stud welding equipment for doing our installation work. But we had so many problems with stud welding that I said, how can somebody work with this technology? So we went about thinking, how could we improve that technology? And that's how we designed our own piece of equipment. And that's where we are now. It evolved into the machine it is now, into one of the better technologies on the market, especially for the refinery work, but also in other industries, civil, shipbuilding, nuclear industries, power generation. It can be used everywhere.
Okay, and this actually started. You started this entire thing in your garage. Is that correct?
That's correct. I didn't have any money.
As
So
most startups are. I mean, everybody starts up with zero money, and that's what makes it so difficult. But one of the
yeah.
questions that I had from an installer was on there was a bit of an argument on site between inspection and the contractor on the amount of leads that can be connected to these machines. Is there any limitation to that?
No, well, basically there is a limitation. It depends how heavy the machine is. If you want to push your current down the line, obviously you need a lot of power, and that power comes from a transformer. So if you want to have a long cable on there, you need a big transformer. And our machines are overrated. They can do much more than what it's designed for, because of the issues on job sites where you need a long cable. And the longest cable that we've ever used is 180 meters, which is closer to almost 550 feet from the machine.
And that's substantial in order to continue with the maximum power for the weld.
Yes, it was quite a big machine, so we were able to do it. And we were welding, I think, up to half-inch studs at that distance.
Okay. Okay. And then, so speaking of the welds, is this stud weld is actually a pin weld. Is that correct?
Yeah, it's a stud weld like very much other stud welding equipment,
Hmm.
except it's the technology of the drawing of the arc and the movement of the stud, because it moves up and down, and the termination of the arc is all computerized. So the technology is different, but the process is the same.
Okay, I see. So is that in compliance with as far as normal refractory installation, as far as API, the 936 and the 982, as far as like, say I know different facilities like Exxon may have a different spec, but they still follow the API, but their welding layouts are like every other cell, and then every other row, every other cell.
Mhm.
And this pin weld is strong enough to comply with that?
Yes, absolutely. The weld surface area, because it comes from inside out, basically, the whole surface area of that stud is welded. So it's a 10 millimeter stud, which is just over 3/8 of an inch. If you work out the surface area of that weld, it's much higher than the surface area of the weld that you do with a stick weld.
Okay, okay. And then this is on the Speed Hex 3, and from what I'm understanding, you now have a Speed Hex 6.
That's correct. We have a Speed Hex 6, which is also with just one stud, but it's much bigger and it's twice the size, so you can actually weld two Speed Hexes at the same time, keeping the same hexagonal configuration.
And what does that do for as far as speed goes? I mean, it was already, from what I'm hearing, that from the installers, that it's about 50% faster already, and then now with the 6, is that going to change
It
the
doubles
the
the
speed of
speed.
the turnaround?
Yeah, it doubles the speed.
Doubles the speed. Okay, that's
Yeah.
that's pretty cool. I like that. And then of course it's not only on the Speed Hex. You have curl anchors and, from what I'm understanding, monster tabs now too, or a
Yes,
version of monster tabs.
we have monster tabs. We can design any monster tab you want, depending on the lining that you have. But we can go up to monster tabs up to 8 inches, for instance, and these can also be shot with our machine.
Okay, so where do people go to order your anchors?
They come to us through our offices around the world. We have offices in Humble, in Texas, and they can come there and get an inquiry for the products, or they can go to any other location. We have a Silicon Asia, which is in Japan, and that's for the Asian market. So anybody who's, let's say, Taiwan, Vietnam, Thailand, Indonesia, they go to our Asian office and they can place their orders there.
And they can get your contact through the website. Silicon, is it
Yes, we're on a
silicon.com?
website. Yes.
Okay, and the shipping, is it you have a lead time of any sort?
We have, it depends on if it's a turnaround. Let's say if it's during a turnaround and they have a lot of discovery work, what happens normally is they will do the demolition whilst we make the anchors, then we will fly it out to location. Amsterdam is a great hub where you can just about ship to any corner of the world. The United States is like almost within 48 hours or 72 hours we can get the product into the United States during the turnaround, and otherwise we would ship by sea if it's like a project for long term.
Okay, and then these rapid arc welding machines themselves, are they available for purchase, or are they rental only?
They're rental only at the moment, because we tried selling them, but we haven't found that the selling module is very efficient. The problem is that the owners of the machines don't really take good care of it, that we've seen in the past, so they break down and then you're always trying to help them. So we decided not to sell them anymore and just to lease them or rent them. And if they're broken, they just get a new machine, and just makes it very easy for us to handle any problems that we have on site.
Okay, I see. Well, is there anything else you'd like to add?
Well, I'm very interested in knowing from the end users, like the OEMs, what their needs are for the turnarounds, because I know it's a very expensive turnaround, especially when it comes down to FCC. What would they like to see be improved? Because we are totally geared into offering solutions for our customers, especially in the FCC. What are the areas that they'd like to see improvement? Is it the speed? Is it the way the refractory is installed or the anchors are installed? What is it that they're looking for to let's say improve their turnarounds?
Yeah, well, I mean, right off the top of the head, definitely speed, cost, and longevity. I mean, that's just probably what they're looking for. But these engineers for some of these facilities have reached out to me, and they were actually requesting some anchoring manufacturers. So it was really lucky that y'all wanted to reach out and be a part of the podcast.
Yeah, well, we have always in our vision statement, we want to support this industry as best as we can, because we know that refractory is a difficult market sometimes. There are many types of refractories in the market. Every unit may have a different type of refractory. The lifetimes can vary very much between FCCs, and we just don't know why one would last longer than another one. Mm-hmm. It's like almost how do you say, it's a science that is not a science, as it were.
Yeah, there's definitely a ghost of the machine somewhere in there.
Yeah,
definitely.
And what we've done is with this with the Speed Hex the full FCC solution that we have at the moment, which encompasses not just the Speed Hex 3 on Speed Hex 6, but we have a lot of speed tabs. We have the mega tabs. We have special other terminators. It's all part of the FCC solution. And we can almost guarantee that customers will not have problem for 10, maybe 15 years. It's been in the market for 10 years. It hasn't shown any faults at all. And we're hoping that at one stage or another in the future, we will be able to give a 10-year warranty on the lining. And that would be something that I think would be beneficial for the end users, because that's what they need. They need predictability for their linings.
Yeah, that was one of the questions I had for our inspectors here. I was asking, have they inspected a lot of this Speed Hex? And they were saying it's just now starting to come around where they're getting into it, as far as over here in the U.S., where they've been inspecting it when it's been in service now for 4 years, and it's a second year run now. They're on 8 years, and they're saying that everything looks fine, everything looks pretty good most of the time. They weren't really able to give me specifics on any kind of failures or anything like that. Probably because they knew I would say something on here that they didn't want to let me know. I mean, that's what happens a lot. I ask questions and people know, "Are you going to say something, aren't you?" And I'm like, "Yeah, probably." I'm just asking questions. I'm just very curious. That was the whole point of this podcast, is because there's a lot of things that I don't know about this industry. And I like the guests to come on and educate me as well as the audience. And that's kind of the whole point. So that's why I asked the questions that I ask.
Yeah, and one of our customers has actually done an extrapolation. They've done tests and they've extrapolated that they expect that it would last 25 years in their FCC units. Wow. Yeah. Well, so that has even surprised us, actually. We didn't expect that much, but 10 years we knew that would be possible.
So the hex is lasting longer than the material is, huh?
Excuse me?
The hex is lasting longer than the material is?
Well, yes, it is, because it's also a casting. It's not a wrought material, it's a casting. And a casting usually has a higher carbon content, whereby the resistance or the wear resistance of the material is higher as well.
Okay. Well, I appreciate you joining us today. We'll definitely have to do it again sometime.
Definitely. I'd enjoy that.
Okay. Well, thank you, sir.
Okay. Thank you very much.
All right. Bye-bye.
Bye.